Questions 13 through 16 are going to be problems where we have to solve a quadratic equation. Now, the first thing is how to recognize that we have a quadratic equation. Quadratic means we're looking for an x squared, and equation means we have to have an equal sign. So if you go back and you look at questions 1 through 12, you'll notice that none of those had an equal sign. So when you're solving a quadratic equation, you're going to follow these 4 steps. First, you're going to get the equation in standard form, which means we need it equal to 0. The second step is going to be using one of those methods from questions 1 through 12, and you're going to factor the equation. The third step is going to be the zero product theorem, which means take each of those little factors that you got and set them equal to 0. And then finally, you're going to solve those little equations, and they're going to be just like 1 or 2 step equations. All right, question 13. Step 1, get the equation in standard form. Remember, that means equal to 0. Our equation that they gave us is already equal to 0. Step 2 is to factor. All right, so when I look at 8 and 28, I know that I can do a GCF, and I can take out a GCF of 4x. So I'm going to factor this one using GCF. So I'm going to write 4x, and then what am I left with when I divide? I'm left with 2x, and I'm left with -7, and that's going to be equal to 0. Okay, now we factored it, so we're going to move on to step 3, which is the zero product theorem. We're going to set each of our factors equal to 0. So we have 4x equals 0, and we have 2x minus 7 equals 0. We're going to solve each of these equations. First one, we just divide by 4 on both sides, and we're left with x equals 0. That's our first solution. To get our second solution, we have to add 7 to both sides of the equation. And then we divide both sides by 2. And our second solution is x equals 7 over 2. And that's it. All right, number 14. Again, the equation is already in standard form. It's equal to 0. So now we need to figure out, how do we factor this? Well, we have a trinomial, and we have a coefficient greater than 1 in front of x squared. So remember, our first step is to multiply the first times the last. So we multiply 3 times 5, which is 15. Now, we're going to list our factors of 15 and find the set of factors that adds to 16. So here's our factors. And we can use a +1 and a +15. That's going to add to give us 16. So remember, we split the middle term. So now we have 3x squared plus 1x plus 15x plus 5 equal to 0. So now we have 4 terms, and we're going to start using grouping. So I'm grouping. And the GCF that I can take out of this first group is an x. And the GCF that I can take out of the second group is 5. So now I have x. And when I divide, I'm left with 3x plus 1. And then I have a plus 5, because that's my GCF. And again, when I divide, I'm left with 3x plus 1. Now I have my matching binomial, 3x plus 1, and I also have x plus 5 equal to 0. So now we're done with step 2. We factored. Okay, the next step, remember, is to set each of those factors equal to 0. So I have 3x plus 1 equal to 0, and I have x plus 5 equals 0. All right, to solve this first equation, we're going to subtract 1 on both sides. And I have 3x equals -1. And then I'll divide both sides by 3, and I'm left with -1/3 for my first solution. On the second equation, this one's easier. We just subtract 5 on both sides, and our solution is x equals -5. All right, question 15. Now, right away, we can see this question is going to be just a little bit harder because it's not in standard form to start. So our first obstacle is to get this equation in standard form. On the right side of the equation, we need to distribute that x into the parentheses. I'm going to copy down the left side. 3x squared plus 2x minus 24. And on the right side, I'm going to distribute the x into the parentheses. So now I have a 2x squared and a minus 3x. But remember, this needs to be equal to 0. So I need to get rid of everything that's over here on the right side. So I'm going to subtract 2x squared on both sides of the equation. And I'm going to add the 3x to both sides of the equation. So now when I do my subtraction and my addition, I'm left with a 1x squared, a 5x, and I'm just going to bring down that negative 24. So we have our equation in standard form. Now we need to factor it. We have a trinomial. We do not have a coefficient in the front. So we know we are looking for the set of factors that's going to multiply to give us negative 24 and add to give us a positive 5. So let's list our factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now remember, we need to add to get a positive 5, so I'm going to use the negative 3 and the positive 8. That's going to give us a positive 5. Okay, so I can come over here and I can just list those. X minus 3, x plus 8 equals 0. So now we've factored. Now remember, the next step is to set each of those factors equal to 0. X minus 3 equals 0. X plus 8 equals 0. And now we solve each of those equations. I'm going to add 3 on both sides of this first equation, and that leaves me with x equals 3. And on this second one, I'm going to subtract 8. I'm left with x equals negative 8. All right, question 16 is a word problem. We're definitely going to have a word problem on our test. It says the area of a rectangle is 40 square centimeters. So this problem is talking about area of a rectangle, which we know the equation for area is length times width. And it already told us in this first sentence that the area is 40. The length of the rectangle is 2 centimeters less than twice the width. So it says the length is, which is equals, length is 2 centimeters less than twice the width. So I'm going to write 2x twice minus 2. And for the width, we're just going to call the width x. So now we've written down this information, and we're going to go back and plug this information into our original formula. So we had the formula area equals length times width. And we know that the area was 40. We know that the length was 2x minus 2. And the width was just x. So again, we have the obstacle of getting this into standard form. We need to get it equal to 0, but first on the right side, we need to distribute the x. So we have 40 equals 2x squared minus 2x. This time I'm going to put my 0 on the left side so that I only have to move the 40 over to the other side. And when I move the 40 to the other side, it simply becomes a negative 40. Okay, looking at this equation, 2x squared minus 2x minus 40, I see that everything in this equation needs to be divided by 2. So now I have 0 equals x squared minus x minus 20. That's my GCF step. Now I need to factor this. I have a trinomial and I don't have a coefficient in the front, so I'm looking for the factors of negative 20 that are going to add or subtract to give me the negative 1 that's in the middle. So I have 1 and 20, 2 and 10, 4 and 5. And if I want to get a -1, I need to use a +4 and a -5 for my factors. So I have 0 equals x plus 4 and x minus 5. Okay, the next step, remember, is to set those factors equal to 0. So I have x plus 4 equals 0 and x minus 5 equals 0. And solve each of these equations. Subtract 4 on both sides. My first solution is x equals -4. Now remember, x represents the width of our rectangle. And could we have a -4 centimeters for the width? That solution just does not make sense. So we're going to cross that out. Cannot have a negative width. Okay, now let's solve the second one. We add 5. And we get x equals 5. That makes sense that the width could be 5 centimeters. Now to get the length, we simply take our width and plug it into the length equation. So we have 2 times 5 minus 2. That's 10 minus 2, which is 8. So for the length, we get 8 centimeters. And if you take the length times the width, 8 times 5, you end up getting 40.